Okay, so we see here that we've drawn this non-stage piston 33 with these on all the time. And the truth is, with these are what we call half duplex systems. In other words, this transceiver is on and this one is off. And then this transceiver is on and that one is off. This talks to this talks to that. And they don't both talk to each other at the same time. And that's half duplex transmission protocol. It is happening so fast at the human being perception level that it basically appears, or there's nothing wrong with drawing it, like these radio beams were on all the time. And we're going to leave that way to show what we're trying to show with this particular instructional video. So we're going to select this piston, and you can see that if we take this piston and move it, that as it moves inside of the cylinder, the piston, the external diameter of the piston is the same as the internal diameter of the cylinder wall, so that there is a continuous, smooth, tight metal to metal contact between the piston wall external curved surface against the cylinder wall internal curved surface. And that's what makes it so that you don't have the leakage of this radio frequency energy, which we would see if they weren't in close contact, but they are, because it has to be in close contact in order for it to maintain its watertight nature. And you can see that in this particular setup that I've drawn, that some of the piston head transceivers are beginning to talk to this SRQP, A, B, C, D, E, F, G. That's why it goes P, Q, R, S, T, U, V, W, X. That's how the convention would be. And as you move it, which particular piston transceiver is talking to which particular cylinder wall transceiver just depends upon where the piston head is. Remembering that the from a relative motion viewpoint, we are considering the piston as moving and the cylinder wall is not moving. And we can go over here. One of the things we're working through with this double width is that, as a matter of fact, if you had this ceramic configuration, then the effect of this beaming of the piston wall transceiver would be that the output shape of the radio frequency beam from the piston wall transceiver would have some width to it, so that if the piston wall transceiver turned a little bit, and by turn I mean and again, by turn, I mean this type of a turning motion. And you can see that I forgot to select. So if you had a turning motion, it would turn those transceivers, but the width of that energy output of those transceivers would continue to have energy moving up into these cylinder wall transceivers. And the final thing I wanted to show was that remembering as this radio frequency energy comes out of here, it's going to run into that. And it's going to have this shape. In other words, it wants to come out and go up this way, but at this point, this radio frequency energy runs into the metal of the cylinder wall. And so what's going to happen is, and I've drawn this here, this would not look like this here, because this piston is not inside of this cylinder. But if the piston was inside of that cylinder, the effect that you would see is that this energy is trying to come out and go all over everywhere, but it runs into the wall, the metal wall of the cylinder, and the only thing that comes out of the cylinder would be this shape of a radio frequency output.